Hi. Today we're going to start our unit on matter and jump in with some notes about what matter is and how we can classify it. And so you should pause the video as we go through to make sure that you are getting the notes copied in your note guide or your notebook. Ready? Okay, so matter is basically everything in the universe. Anything that you can think of is made up of matter. And the definition of matter is that it is anything that has mass and takes up space. So that could be the air around you because it takes up mass and has space, or has mass and takes up space. It could be you yourself. It could be mostly anything as matter. Things that aren't matter would be like an idea or stuff like that. This chemistry is defined as the study of composition, structure, and properties of matter and the changes that the matter undergoes. So what is this thing we're looking at made of, and how does it change when we do X, Y, or Z? That's basically chemistry. And the building blocks of all matter are called elements. Elements cannot be separated or broken down into simpler substances by chemical means. They're the ones that you find in the periodic table. Those are the basic building blocks of all matter. And if you took an element and started, like let's say it's a giant hunk of copper, and started chopping it up, the smallest part of that element would be called an atom. So whatever copper's melting point is, copper's boiling point, copper's density, all those things, if you had a big chunk of copper, you start cutting it up, one atom of copper would have the same properties as that giant chunk of copper. But if you take that atom of copper and you start slicing that up, well, then you're not going to be copper anymore. So on the periodic table, there's lots of different elements, and there's some that are super common on Earth or in your body. There's a little table here. You can see oxygen is common in both. Iron is very common in the Earth, also in your body, but not a ton of it. Silicon is very common in the Earth. Sulfur and carbon, these things that are found pretty commonly. Most chemical compounds are made from like 20 to 25 different elements. Some elements are really rare, and so you don't see them very often. Some of them don't last a long time in nature. They decompose into other things, and so again, they're not around for very long. But that's just a little table of how some common elements can be found. You can take elements and you can put them together to make compounds. You have to chemically combine them, and that's called a compound. So take two atoms of two or more different elements, and then start to put them together, two or more atoms. It doesn't have to be just two atoms, it could be lots of atoms, and chemically combine them, and that is called a compound. Compounds have unique properties, just like elements do. Each element is different, each compound is different. And each compound is not only different from other compounds, but they're also different from the elements that the compound contains. What's important though is that whenever you make, let's say, a specific compound, like let's say water, the elements that combine to make water always combine in the exact same proportions. So, you know, the formula for water is H2O. There's two hydrogens and one oxygen in each molecule of water, and it's always exactly the same proportions. So molecules are like atoms. How atoms are for elements, molecules are for compounds. If you took a bunch of water, and water we know has a certain melting point, boiling point, and density, it's all this stuff, all these properties, and you start chopping that water up and start separating it out, you can get down to the size of one molecule, one H2O, little formula unit, one little guy, H2O floating around. That little molecule has the same properties as the glass of water. If you take the H2O and you take off one of the hydrogens, well, now it's different. It wouldn't be water anymore. So a molecule is the smallest representative unit for a compound, and an atom is the smallest representative unit for an element. These are some pictures of molecules. You can see water has one oxygen and two hydrogens. Oxygen molecules, like the O2 that we breathe in the air, have two oxygens. And the little number here that represents the hydrogen, this little number represents how many oxygens you have. Sugar, sucrose, which is in basically everything, you can see it has 12 carbons, 22 hydrogens, and 11 oxygens, all in this giant molecule here. So this molecule of sugar, it's arranged in a very specific way, and it has this very specific formula, and that formula is the same for every molecule of sugar. Atoms can join together and make all sorts of molecules, millions and millions of. Again, most molecules are made just from like 25 different things, but the possibilities truly are endless. So those are pure substances, any element or compound. A pure substance, if we're going to classify things, is anything that has a definite chemical and physical property. So every element, every compound, anything with a chemical formula, we consider a pure substance. And pure substance, underneath it, you have two different things. You've got elements and you have compounds. So pure substances have definite chemical and physical properties. They have a formula that you can look at. An example of pure substances would be things like oxygen, sugar, gold, hydrogen peroxide, carbon dioxide. All these things have chemical formulas, and we know they go in the same portions every single time, and we know what their properties are every single time. Elements and compounds are both considered pure substances. Mixtures, on the other hand, are taking elements and compounds, and they're not chemically combined, you're just physically mixing them together. The big difference between mixtures and compounds is that, or mixtures and pure substances, is that you can separate a mixture of like dirt and water. You can separate it. You can pour off the water and the dirt's at the bottom. A mixture of sand and grass, you can filter it out, or you can pick pieces of grass out to get the different things out of it. So that's a mixture. A salad, you can pull out all the lettuce, and then you're just left with radishes or whatever. So that is a good example of how mixtures and pure substances are different. If you have a molecule of sugar, you can't just physically pull off one of the oxygens. That's impossible. So pure substances are different, and mixtures are different that way. Underneath mixtures, you've got two kinds of things. You've got heterogeneous mixtures, and you've got homogeneous mixtures. Heterogeneous mixtures are ones where they're not uniformly distributed. I already mentioned a few of them, like a mixture of, like, let's say, sand and grass. Or even if you just went to Lake Marion and walked on the beach and grabbed a handful of sand, took a step and grabbed another handful of sand, they'd be two totally different handfuls of sand. Those are heterogeneous mixtures. A salad, every time you jam your fork into a salad, you get something different. Maybe one time you get, like, a wilted piece of lettuce and a gross tomato, and then one time you get like a crouton and some bacon chips and some cheddar cheese, and you hit the jackpot. So every time is different. That's a heterogeneous mixture. I tend to think of taste, but you shouldn't obviously taste things in chemistry lab. Homogeneous mixtures, on the other hand, are uniformly distributed. So the mixture is the same every single time. Think of anything that you buy at the store to drink. Every Gatorade you've ever bought, every Diet Coke or whatever you've ever bought, every single drop tastes exactly the same. That's a homogeneous mixture. There's no chemical formula for Diet Coke. There's no chemical formula for Gatorade. It's a mixture of a bunch of different gross garbage that they've added a ton of sugar to make seem like it's kind of delicious. Every mixture you can separate by physical means. It's really important. You can't do that with elements, and you can't do that with compounds. But for mixtures, you can. If you wanted to separate out the components of Diet Coke, you could do that. You want to separate out the water and the sugar in your Gatorade, it's not hard to do. That is the definition of a mixture. And I think that's going to be it for right now. This has been a great chat to see you, and I hope everyone is well. Take care of yourselves. Be nice to each other. Okay, bye.